Hey guys, today we're going to talk about variation, okay? There are two forms of variation that we're going to cover in this class. And you've actually seen one of them since Algebra 1. It's called direct variation, okay? So you have direct variation, okay? And all direct variation simply means, okay, I'm going to show you a function for it as well. But all it simply means is that as x goes up, y goes up. And so then what is the opposite of that as well? As x goes down, what do you think happens to y? What do y'all think happens to y? Y goes down. Absolutely. Okay? That's direct variation. Okay, now there's a formula for direct variation. That is y equals k to the x. Now, we call k the constant of variation. Okay? You need to know that. Okay? K is called the constant of variation. Okay? And in most variation questions, that's what we're taking our time finding, okay? We're taking our time to find the constant of variation. Constant of variation. I'm just going to put V. Okay, so this formula should look very familiar. It looks like a line formula. That's right. It looks just like a line does, right? Do y'all remember lines? It was y equals mx plus b. Kx, all right? This is just a line. This is just another way of writing a line, okay? Y equals kx, where k is the constant of variation. So you might see something like y equals 3x. Well, one, that's just linear, okay? This just means it's direct variation. In other words, 3 is your constant of variation, okay? So we call that k, all right? And all it means that as the bigger x gets, the bigger y gets, all right? That is your constant, that is direct variation. That is the whole idea about direct variation. As x goes up, y goes up. Okay? And so that would be the equation for it. Alright? So, you could say something like, z varies jointly with x and y. Okay. So, let's look at this real fast. Z varies jointly with x and y. Do you know all that means? Z varies jointly with x and y. Guys, it's just another way of saying, my brain's all over the place. This is just another way of saying z has direct variation with x and y. So if z has direct variation with x and y, then that means that as x and y go up, what does z have to do? Go up. So you can just write this one as z equals kxy. Alright? If you see something that says this variable varies jointly with this variable, that's assuming direct variation, okay? You can assume direct variation unless told otherwise, okay? So then what is this other form of variation? I keep talking about direct, so what's another form of variation? Indirect. Another word we might say that is called inverse, okay? Another word you might hear say is called inverse variation, alright? So inverse variation means that as x goes up, y goes down. And as x goes down, y goes up. Okay? So, a formula you might see for inverse variation is something that looks like this. Y equals k over x. Okay, so first, that's just your basic inverse variation, okay? Formula. You should write those down. You should have written all the formulas down so far that I've given you, okay? But this is your basic inverse variation, alright? Now, I can make it more complicated by saying something like z varies jointly with x and y, and inversely with w. Okay, so this is not meant to be confusing, but I want to make sure I cover it. Okay, so it says z varies jointly with x and y. So what did we just talk about? That means there's direct variation with x and y, and inversely with w. So that means there's inverse variation with w. So another way of writing this guy could be z equals, don't forget your constant, k. Okay, now, how does it vary with x and y? Directly, right? Because it just says z varies jointly with x and y, so that's direct variation. So kxy. But then how is it varying with w? Inversely, so that means I should have over w. Okay? So, hopefully you've written every formula down, because we're going to need them. Okay. I'm not trying to make this super hard, but I just want to make sure you have you see kind of what's going on. Basically, if it says something varies jointly, that's representing direct. If it says something varies inversely, that's representing inverse. All right, this means you're going to divide by it. Okay, so let's look at an example. Okay, suppose x and y vary inversely, and x equals 4 when y equals 12. Model that function. Okay, so first off, let's think about what this means. Inverse variation, x and y. Let's just think x and y varied inversely. What would that look like? Y equals k over x. Hopefully you already had that formula down. Hopefully you were jumping and say, oh yeah, that makes sense. Okay. So now, there are 3 variables here. Okay. How many variables are you left to have in a function? 2, right? So you're kind of like, well, I can actually find out what k is, because what is k? K is not meant to be a true variable. I don't really want to change k. I just don't know k at this moment. Because do y'all remember what the definition of k was? Constant of variation. So it means that k is just some number and it stays that number for that entire problem. Okay? I'm not trying to write a function where I can change k all the time. I'm trying to write a function so that I can plug in different x's and get different y's. K is just a constant number. I need to figure out what that constant number is. Alright? Well, I can use the given information from right here. X equals 4 when y equals 12. So I can say 12 is equal to k over 4. Okay, let's solve for k. Well, if k is being divided by 4, what's the opposite of division? Multiplication. So multiply both sides by 4. And that gives me 48 equals k. So now I can write my function. Remember, you want your function to look like this, but where k is some number. So in this case, my actual answer is y equals 48 over x. I don't know why I said k. That's an x. That's an x. That's an x. I messed up there. I meant to say x. All right. So y equals 48 over x. Boom. That is it. All right. Let's do another. Okay. So our next example. The volume V of gas varies inversely to the pressure P. Pause. Hold up. Volume V varies inversely to pressure P. So that means V should equal K over P. Okay. So, 1, that's my formula I'm going to somehow manipulate and work with. Okay. The volume of a gas is 200 centimeters cubed under pressure of 32. Whoa. They just gave me 2 pieces of information. They told me the volume is 200. They told me pressure is 32. What could I use with these 2 pieces of information? Pause this video. Try to figure just this next part out. You should be aware of now, after just trying this problem, hopefully you paused and unpaused right now. Okay, you should be like, oh, I could find my constant K right now. I could find my constant K by plugging in 200 for volume and plugging in 32 for pressure, because constant is always the same number for that problem. It doesn't change. Okay? It changes from problem to problem, but it doesn't change for that overall problem. You're trying to create formulas where you can change P and V at will, but K is just the same number every stinking time. Okay? So you have 200 is equal to K divided by 32, so I can solve for my constant by multiplying both sides by 32. Alright, I honestly don't know what 32 times 200 is. So if my calculator would turn on, I would use it. There it goes. 32 times 200. And I get 6,400. So I know that my constant, K, is 6,400. Now, what will its volume under pressure of 40 kilograms per centimeter squared? So now I want to figure out volume when I'm given a specific pressure. So I could say V is equal to, but I know what K is. So I can plug in 6,400 over, and then they gave me what P was. P was 40. So I can just say V then is equal to, cancel out the zeros, you can just use a calculator too, 640 divided by 4. 640 divided by 4, 160. So I know its volume is 160 centimeters cubed. Boom. Boom shakalaka. Alright, that's how it's done, guys. Alright, guys, I hope this video made sense. Let me know if you have any questions. On your homework, there's graphs. Just remember what inverse and direct means, or jointly means, okay? It means as x goes up, y goes up. So when you're looking at a graph, just simply go to the right. Is y going up the more I look to the right? Or is y going down the more I look to the right? If it's going up, direct variation, or joint variation, whatever you want to say. Alright? If y is going down, indirect, or inverse variation, whichever one you want to say is fine. Alright? Okay, guys, let me know if you have any questions. Send me a remind. Send me an email. I hope you guys have a great day.